Hey y'all, Data Guy here. And today I wanted to show you how you can build a pipeline to run predictive analytics jobs. So basically what I'm going to show you here is an end-to-end project that is going to collect some stock data from a publicly available API. It's going to store it in an S3 database. Then it is going to take that data, vectorize it using open source vectorization formulas. And then what we're going to do is take that data and bring it into Weaviate vector database, and then use some, again, linear regression algorithms to actually calculate, hey, what can we predict the stock price will be in a week's time? Obviously, don't make any stock choices based on the results of this formula, but I just wanted to show you this because it's a good kind of method you could apply to really any kind of simple linear regression predictive analytics job, and using vectorization and ML best practices to do it a lot more efficiently than traditionally done. So without further ado, let's get started. So the first thing we're going to do is create a new Airflow environment to actually run all of this. So to do that, we're going to cd it to desktop, repos, and then stock data processing, let's call this. Then we'll cd into that, and then run astro dev init to generate our file structure and not type it in wrong. So type in astro dev init or this, and then we can open up our folder that we just created. So go to desktop, go to our stock data processing, and boom. Now we have a simple basic Airflow environment that we can start building our pipeline in. And so the first thing we are going to want to do in our pipeline is actually set up our requirements.txt file with all the necessary packages and requirements. So here, what we're going to do is go into our requirements.txt file, and we're going to import a few different packages. So the first one is our HTTP sensor, so import that. Then we're also going to be using this HTTP provider, our Amazon provider here for that S3 bucket, OpenAI for the open source vectorization formula, the Weaviate provider to actually use a Weaviate database to store those vectorized data points, the requests so we can interact with and process and query JSON data. Boot23, this is basically just a shell to interact with S3 buckets. OpenAI for, you can tell, the exact same purpose. Weaviate client for the same purpose as Weaviate. Pandas, scikit-learn, just standard data science tools as well that we'll want to have in here. So then what we'll do is go to start creating our DAG. So stock data processing.py, and then once we have our DAG file open, we can start bringing in all those requirements. So here we'll bring in a whole laundry list of requirements, basically just all the ones that we imported earlier in our requirements.txt. So I'll only call out stuff that's interesting here. So just a local file system S3 operator for just uploading our stock data from, effectively it's going to be our local file system to our S3 bucket. S3 hook, create object, embedding operator, Weaviate operator, we're going to use a Python virtual environment, and then linear regression for actually generating our predictions. So then now that we've gotten all those set up, we're going to set a full list of creation details. So use your market stack API key. And so just so you know what I'm talking about here, window, so market stack API. So you can just go here. This is just a nice little real-time stock data website, and then you can get an API key, super easy to do. And so here you also get an S3 bucket name, S3 access key, secret key. I'm not including these in here in mine for obvious reasons, but I'm going to set them out and actually run this. And then your Weaviate URL for wherever you're hosting your Weaviate database. And I personally am going to be hosting this locally, so it's just going to be like a local host 8086, I think I'm hosting it on. So just wherever you're hosting your Weaviate database, put that URL there and make sure that if it's not accessible over the public internet, you kind of figure out a way to route that. Or just run a demo example locally, like I am. So now that we've gotten everything in place in terms of variables, we'll also just have a default set of args here, just some classic basic stuff. Won't bore y'all with the details, you know what it is. Then we will create our DAG object. So here, just create a DAG, define DAG, start stock market analysis, default args, and just simple DAG to collect, process, analyze stock data. And then we can define our tasks. So the first task we're going to find is actually fetching our stock data. So here, what we're happening is we're going to build a URL using this base API market stack endpoint, and then just injecting our access key into it using a Jinja template. Then after that, we're executing a request.get using that request.get to pull information, JSON of that market data, opening that, and then just dumping it into a temporary file space under the name raw stock data JSON. So just storing it on our local file store as an intermediary location before we transfer to S3. We're also here going to define a vectorization task. So here, what this task is going to do is ingest that stock data, open it, dump it, and then create embeddings out of it using this OpenAI embedding model. So this will just take that data, turn our raw text and stock and data into just numbers, which will be much easier for the underlying machine learning model to actually consume, set our vector response, and then just return our vector and data. Then afterwards, we'll save that set of tasks, actually save all this to Weaviate. So here, save to Weaviate, vector, metadata, using our Weaviate client with the URL we already set earlier. Then we are creating a data object. So when you're dealing with vector data within Weaviate, you have to create a data object that represents it. So in this case, it's going to be stock data. Then, once we're done with that, we can move on to defining our regression analysis task. So here, what we're going to do is define a task that is just going to open up our Weaviate client. Let me add it here. So after we save it to Weaviate, this will run. Where we're going to open up our Weaviate client, get our data object, or anything with stock data, data object label, then add them all into a vector, or just an array of vectors, add all the metadata for them, again, into a array of vectors, or array of metadata, then create a data frame out of that metadata, set the X of our array that we created earlier, the MP array, or of a NumPy array with that data. So here, taking those vectors, creating a NumPy array, and then adding the stock price, the values to our stock price data frame. And that is the stock price that we're collecting from this stock data object. Then selecting the linear regression model, fitting our X and Y so it knows we're trying to predict the stock price using the rest of the stock data. Then getting the next week's data. So this is just a function which you'll see down below. We're going to then vectorize that data and then use that data to predict what the next week's vectors, or what the next week's data, and therefore stock prices will look like. Then we're going to dump all those resulting predictions into a JSON file on just our local machine. So now that we've gotten our regression analysis task done, we'll then create a few more tasks. So here, have a define get next week's data. So this is where, it says get or simulate. So I really screwed up calling this get next week data because it's really just going to be fetching the last 7 days of data from Weaviate to predict the next week. So I need to work on my variable and function naming conventions. So this is just going to fetch the most recent data from Weaviate and then use it to predict what the data or what the stock price will be in the next week. So that's what's happening there, just pulling that data from Weaviate. And then we are going to define a few Airflow tasks. So number one, an HTTP sensor, which is just going to check that market stack API for any new data. So every time the data updates within the market stack API. So we wanted to show you how you could design this to constantly ingest data from a source and then process it and then use it for predictions, because that's what a lot of times you're trying to do with predictions is you need to have the freshest, most recent available data to actually be making accurate predictions. So really critical to just have a mechanism that's doing this on a regular basis, and then just calling that task as fetch data task. After that, we'll define also our upload to S3 task. So here we're uploading that raw data, stock data JSON that we saved locally into an S3 bucket with the name that we defined up at the top. And then just using the replace method to replace old data so we don't have any legacy data sticking around. Then we have our vectorized task where we will put in vectorized data, fetch data task, and then our save to Weaviate task, again, just calling this so that we are saving the output of this vectorized task into our Weaviate database. And then finally, executing our Python Python task in a Python virtual environment. Again, just doing this because I want to show you different ways that you can execute these files, because a lot of times in machine learning, you might actually need to use a different type of Python environment. You might need to use a different type of set of packages outside of Airflow to actually run your pipelines. And then all we're doing after that is just defining our dependencies, and we should be all set. So start this up, take in the Airflow UI, and we can show you what it looks like.